Good day and welcome. I'm Jack Van Horn from the University of Virginia, and I'm proud to welcome you to this edition of our 2021-2022 Foundations of Biomedical Data Science Seminar Series. This lecture series is supported by UVA's Integrated Translational Health Institute of Virginia, the UVA Brain Institute, the College of Arts and Sciences, the School of Data Science, and through a grant from the National Institutes of General Medical Sciences. This year's theme is Ethical Challenges of Artificial Intelligence in Biomedicine, where we enjoy presentations on Fridays from leading thinkers about the promise, opportunities, and the hurdles associated with AI applications in the biomedical sciences. Selected participants in our Biomedical Data Science Innovation Lab program will leverage these presentations as vital material for our culminating in-person grant project workshop to be held here in historic Charlottesville, Virginia next June. It is my delight and honor today to welcome our speaker, Dr. Caitlin Wylie from the University of Virginia. Caitlin received her PhD from Cambridge University, and she is here at the University of Virginia's School of Engineering and Applied Sciences, where she is an assistant professor. As a social scientist, she investigates the ways in which people create, interpret data, design research tools, techniques, and construct knowledge in the sciences and engineering. She uses interviews and participant observations to study overlooked collaborators on research teams such as technicians, students, and volunteers. And she teaches engineering students how to assess the social and ethical dimensions of the technology and professional work they are doing so that they can be designed as safely, equitably, and successfully in terms of sociotechnical systems as safely as possible. We are proud to say that Caitlin is also serving as one of our 2021-2022 Biomedical Data Science Innovation Lab mentors. And Caitlin's lecture today is entitled, Ethical AI Requires Ethical Collaboration. Collaboration being a crucial part of science, and yet respectful, knowledgeable, and integration is a challenge to achieve. And in her talk, she's going to discuss the frameworks for thinking about research as a collective endeavor and practical strategies for supporting ethical team science, including how to craft group identity, how to foster an inclusive environment, and how to translate knowledge across disciplines. As always, we are streaming this lecture live and for recording via YouTube. And if you're watching on YouTube, thank you so much for joining us today. And also our specially selected 2021-2022 Biomedical Data Science Innovation Lab participants are encouraged to submit any questions for Caitlin via the chat feature in their Zoom sessions. I will personally synthesize these questions and ask them on your behalf during the last 10 minutes or so of her lecture. And without further ado, we welcome Caitlin. Thank you so much, Caitlin. We are super excited to hear from you today.
Thanks, Jack. Thanks, everyone. Yeah, as Jack said, I really want to make a broader argument than AI in particular, and you could replace AI in this title with research or science or technology, in the sense that we can't do anything, we can't make any ethical products without an ethical process. And so I want to make the argument that a crucial part of ethical research process is collaboration. And so in this photo, that's me in the middle in the green jacket. I'm being an ethnographer in a research lab in the field of vertebrate paleontology. So you might think that's pretty different from AI and medical research. I'm going to disagree and suggest what we can learn from a variety of fields that can inform how we can build ethical AI together across disciplines, across cultures. So in this photo, there are scientists, there are technicians, there are volunteers. There's a social scientist, right? There's various things with which people make knowledge about extinct animals. And so I want to think about collaboration in terms of a broader sense of who is doing the research, not just the scientists, not just the PIs, but really everybody in the room. So first of all, let's think a little bit about what we mean by collaboration. I'm sure you've seen some of these words. They're very trendy, especially among funders. And I want to think about, my scientist and engineer collaborators get caught up on like what the differences are between these words. I think that's less important than the assumptions behind these words. So let's think about what it means to be interdisciplinary, transdisciplinary, multidisciplinary. It assumes that everyone belongs to a discipline, which is not always true, right? As someone who does science, technology, and society as a field, I belong to a lot of disciplines, and the idea that we are working across them suggests that we already belong to one. Okay, so there are limitations with that view. These terms also assume that everyone is separate. Okay, we are co-producing. So again, the idea that disciplines are separate bodies of knowledge and of people, and that can be a barrier by assuming that these disciplines and groups of people actually don't overlap already. And then finally, these words, and especially their trendiness, right? The NSF is very pro convergence research, for example. It assumes that science is not already an extremely collaborative endeavor. And so that made me wonder, like, who counts then as a collaborator? Who are we assuming is a collaborator when we take these frameworks of convergence and co-production and cross-cutting initiatives? What is new about them? So generally, if we're asking who we consider to be collaborators, these are the groups. So scientists or people like me, researchers have great respect for other people with PhDs. So generally we count them as collaborators. Technicians varies a lot by field. In some fields of biomedicine, technicians have PhDs and are authors on publications. In other fields like vertebrate paleontology, technicians do not have a shared credential. Some of them don't have a college degree. They are not considered authors on papers. Their work is considered to be very separate from the research itself. So this is a disciplinary difference that can get in the way of interdisciplinary collaborations. And then, of course, students are a really interesting example because everyone thinks it's good to have students involved in research. But whether they're seen as learners or as collaborators differs a lot based on the context and on the discipline. So sometimes you see professors sort of tempting students to join their labs so that the students can have a paper, so they can be an author on a paper sort of someday after putting in years of effort. And if they contribute enough epistemic, intellectual material to that paper. And so how you define that is really squishy and hard to standardize. And the same goes for volunteers. So some fields of research rely on citizen scientists or amateurs. Vertebrate paleontology is one of them. And yet rarely are they considered contributors in the same way that students or technicians or especially researchers are. Instead, they're considered kind of an outreach effort or maybe like free labor that's kind of nice, but not actually contributing knowledge. And that's wrong, as I'm going to show you through some examples. And then finally, research participants are not considered collaborators. Generally, they're considered like the subjects of the research, which is not a very fair way to think about them. And of course, community members. So all the rest of us who are around these research projects or even living in the site of research projects, we are usually considered the context, the background, not part of the research team. And so I'm going to challenge some of these assumptions and ask us to think more broadly about who we should consider collaborators by looking at these particular categories of collaborators through some examples from my research. So basically, my argument is if we recognize how all of these people contribute to scientific research, we'll learn a lot about how diverse perspectives and experiences help us make sense of the world together, right? Do better research, and how we can do that better. And so I would suggest that there's a moral argument to this more inclusive view of collaborators. And there's a practical argument that we will make better knowledge when we work together. So here are some theories I want to think with. I use these a lot across various projects that I work on. The first is the community of practice. And so this is the idea that we define a community based on the work that they do, their practice, their shared efforts, as opposed to their disciplinary identity or their credentials, because this is more focused on the work and less focused on the past. Okay, so it acknowledges that people can have awesome expertise that they bring to the table, regardless of what degrees they have. And so this theory relies on a notion of learning that is in situ, sort of an apprenticeship model of learning social norms and technical practice, which I think is very true in cutting edge research when nobody knows how to build ethical AI. And so we're all learning how to do it together from each other by doing it. Another theory I work with a lot is called standpoint theory. This comes from feminist thought. And it's the idea that if we're all standing in a valley, our geographic standpoint, our perspective is different from everyone else's. Nobody can share the same view of this valley that we're overlooking. And therefore, it's valuable to have people standing around a problem, if you think of it that way, because they're all going to bring different experiences, different ways of understanding that problem, physically a different perspective, right, based on their identities and what their lives have been like. And this diversity enriches knowledge. It makes knowledge better to have a variety of inputs. And then finally, there's a lovely way of thinking about expertise that points out that those, an insular team, a community of practice that ignores outsiders, is missing out on all of the wisdom that comes from being an outsider. Okay, we all get a little narrow in our perspectives when we're with people who are doing the same things as us, or people we've worked with a long time, and we forget to consider what it's like to look at our team from the outside. And so Etienne Wenger calls this a wisdom of peripherality. Okay, so the wisdom that comes from being outside of a community of practice. And I think that's incredibly important for ethical AI in particular, because the implications of it are going to be broad, and therefore we need to have outsiders, right? Supposed non-experts like community members, and we need their perspectives. All right, so how do we learn about ethical collaboration? By looking at the kinds of collaborators that we often overlook. So as Jack said, I am an ethnographer. I use participant observation and interviews in my research. So that means I hang out in research communities and talk to people about what it's like to do their work. The three cases I'm going to talk about today are technicians in vertebrate paleontology, undergrads who work in engineering labs, and community members who partner with my research team to study the effects of climate change on their infrastructure in their town in Alaska. All right, so let's start with those technicians. The way that scientists think about technicians tends to be in two veins. One is they're part of the machine. Okay, they're part of the laboratory equipment, as you can see from some of these quotes. And that technicians, the value of technicians is being able to be replicable. They just need to do the experiment in a way that other people can achieve the same results. So this is one way. Okay, this sort of grunt work, they're very technical, they're just meant to follow instructions. And yet, if you've ever done research, you know this is deeply untrue, that often it's the technicians who are the only ones who know how to make that machine give the results that you want, or the only ones who know how to fix something when things go wrong. And so this sort of mechanical view of technicians is really ignoring their expertise. And so the image on the right is a fossil preparator holding a tiny drill. So the thing she's holding is vibrating, and it's removing the rock from this gorgeous fish fossil. And you can imagine, like, how on earth could this be mechanical? The level of artistry it takes to remove a very thin layer of rock without damaging the bones underneath is incredible, and has nothing to do with being part of the machine. So this sort of dismissive view of technicians is not only wrong, but offensive. And so the other way that scientists tend to view technicians, and this is how they talk about them, right? Scientists know that their work relies on the value of their technicians, the expertise of their technicians. They just don't talk about it in formal senses, like in papers in some fields. But scientists know. And so they say things that technicians have lab hands or instinct. Okay, there's something unnameable to their skill that is very hands-on, skill-based rather than credential-based. So yeah, for vertebrate paleontology in particular, fossil preparators talk a lot about creative problem solving, that their work really is an endless stream of problems that they have to approach. So like every fossil is individual, every kind of rock is a little bit different, every tool is going to work differently on every rock. And so there's a lot of creativity and problem solving and tinkering and tool design that makes their work possible, of making the fossil visible for the scientists to study. And so if you've read Hope Jaren's 2016 bestseller, Lab Girl, it's about her career as a paleobotanist. And it's really a love letter to her technician, Bill, whom she takes with her across various institutions throughout her academic career, because she knows that her research and her success as a professor depend on Bill's expertise and support and friendship. And so I thought that was a wonderful sort of best-selling memoir view of the actual role of technicians in research. I wrote a whole book about technicians. This book is not actually about dinosaurs, as may be confusing from the title. This is available open access on the MIT Press website if you want to know more about how to think about creativity and manual skills in research. All right, so let's think about undergrads. So universities tout undergraduate research. We all think it's good, right? It's an inherent good. It's got to be good for students. And part of this comes from a perspective of professionalization and training and developing lab skills through learning by doing, learning in a community of practice. And this is evident in the way that the NSF, for example, portrays research experiences for undergraduates or REU programs as educational grants. They're not research grants, which is interesting because it's really paying a student to work in the lab for a summer. And so I found in my studies of engineering labs that actually undergrads are contributing a lot to the knowledge and social community and learning of lab communities. Okay, they're not just sort of passive recipients of what it's like to be in a lab, which, you know, they're learning that too, but they're also contributing back in ways that are not recognized and are actually amazing. So let me tell you some examples. So for one summer, a biomedical engineer was placed in an electrical engineering lab. She was not happy about this. She felt very out of place. She didn't really know anything about electrical engineering, except that this lab was building sensors to try to measure stress in patients. And so the PI of the lab was saying to the lab group of 15 to 20 students in a room, he was saying, how can we measure stress? What about cortisol? Can we measure cortisol? Like, he doesn't know either. He's an electrical engineer. And the undergrad says, well, no, cortisol is not a good indicator of stress because it changes over the course of the day. It changes based on what the person is doing. It's not a reliable indicator of whether the person is experiencing stress. And the PI in the whole room shuts up to hear this undergrad explain this because they don't know. Okay, she's bringing knowledge from another field. She's bringing knowledge from her broad education as an undergrad, as opposed to grad students and PIs who have become very narrow, become very specialized. And she was opening back up engineering knowledge for them. Another example was from a student who was part of a robotics club. And so he learned how to 3D print parts for this robotics club. And he also worked in a research lab, and the lab was building sensors that were going to be put outside. And they were trying to debate how to protect the sensors. And the student said, well, why don't we 3D print a casing? And they were like, can we do that? And so the student ended up designing and printing the casings for these sensors that were the basis of the research lab's research. So it's an incredible contribution, not only of like an idea that came from outside the lab, but also the skills to know how to do it, because no one else in the lab knew how to 3D print anything. And then when that student left, graduated, it was interesting because the lab really scrambled because they didn't have anyone to replace those skills. And then finally, undergrads play this really interesting role in engineering research labs and universities, in the sense that they get really good at particular things. So again, this grunt work idea of technicians and students washing glassware, doing repetitive experiments, and that's boring and easy, and therefore the more junior people in the lab should do it. And yet undergrads would become so good at these supposedly menial tasks that the results would be better. Okay, so later on down the research process, the results were better when a particular undergrad prepared the reagent. And then when that skill was recognized, or when that contribution was recognized, PIs would sometimes say to grad students or to other students, go and learn that technique from this undergrad because they really do it well. So in that sense, undergrads are taking this skill, this task that is supposedly boring and routine and easy, and making visible the expertise that it relies on. And they're then passing on that knowledge to other people in the lab. So they're creating learning opportunities for the grad students, for the PI. And then finally, I've seen lots of examples of undergrads coming up with ways that their research teams could use their methods for other applications. So for example, in the electrical engineering lab, they are really great at building low-cost sensors. And so usually they do these for healthcare purposes and like patient monitoring purposes. And one undergrad said, well, why don't we use them for air pollution monitoring? We already measure indoor environments. Why couldn't we just put one on a stoplight, put a sensor system on a stoplight and use it to predict asthma risk, for example, based on the quality of the air? And everybody else in the lab thought this was brilliant. Like, what a great idea. So again, this undergrad ability to think big and think outside of what might be expected within a particular lab or a particular discipline, this is real intellectual contribution. And so I want to talk a little more about how undergrads create space for others to learn. Because again, we assume that undergrads are the learners here. And actually in my research, I'm finding that they are not the only learners. When an undergrad is present, everybody else learns a lot more. And part of that is because undergrads are expected to be learners, so they can ask supposedly dumb questions, right? No one expects them to know how things work. But most of the time I see undergrads ask questions in lab meetings, for example. All the grad students become really quiet because they want to know the answer. Okay. And they might have too much in the game, too much skin in the game. They don't want their PI to know that they don't actually know how that machine works or why that result looks that way or why we make graphs in this way. And so undergrads reopen these assumptions in ways that are really helpful for the graduate students in particular. Also, I've seen undergrads ask questions about how things work that then the researchers pause and say, I don't know why we do things this way. Let's try your way, right? Or I don't know why this is obviously data, this reading, and this one is obviously noise. I'm going to reject this one, and it's really hard for me to explain to you why. And I've seen researchers really sit down for a few minutes and like analyze their own assumptions. And this reflective work is going to make the research better. It's making the practitioners slow down and think through what they're doing so that they can explain it to the undergrad. And that's going to make them more responsible, more careful in their research. And then finally, many professors use undergrads as judges for grad students' conference talks, for example. Like grad students are often practicing talks, learning how to give presentations in group meetings. And at the end, the PIs will turn to the undergrads and say, like, how did that go for you? How well did you understand that? Because they value the undergrad's perspective as a general listener, right? The undergrads are not expected to be an expert in that field, and the grad students are supposed to be talking at an audience level that's probably about equivalent to an undergrad, because people in the audience at the conference will be experts in various different things. And so undergrads are considered sort of the ideal audience for practice talks, which I think is really interesting. So in that sense, it's sort of valuing the undergrad's ignorance in a way. Okay, the undergrad's ability to understand what is comprehensible, what is clear about that explanation, as opposed to somebody who already understands the field and assumes that they know. So this is an image, a photo of this grad student with the purple gloves. The machine wasn't working right. This is a machine that saws samples in material science. And the undergrad was saying, what's wrong? Like, is it supposed to work like this? And the graduate student stopped and had to like take it all apart to figure out why it was working the way that it was and what the problem was. And so both of them got to learn how that machine worked, really because the undergrad said, should it be making that noise? And then, of course, undergrads offer the opportunity for others to learn how to mentor, how to collaborate, how to communicate, because, the undergrads are around, they need someone to sort of watch over them. And so grad students and professors learn by doing in that sense. And they couldn't do that if the undergrads were not there. And then a lot of grad students and professors talk about undergrads as motivating, that the undergrads are so happy to be there and they're really excited about the research, that the grad students feel sort of uplifted. And even the PIs will say it's so fun when so-and-so student comes to lab meetings because they bring a lot of energy. So my argument here is that undergrads are not the only learners in these communities, and that really everybody benefits when we include students and research teams for the student intellectual contributions, for their contributions of skillful labor, and for their ignorance, basically. Their broad education, their lack of specialization, their lack of assumptions about a particular field, and that those are really helpful for helping the experts think through what they're doing and explain what they're doing. Okay, finally. So community members are a really interesting case in the ethics of collaboration because sort of the field of community-based research and community engaged research is growing in really interesting ways. So I think we can all see arguments for why technicians and students should be considered collaborators for their sort of classic epistemic contributions. And community members is a little harder. It's a little harder for us to understand. So let me talk you through a case in which our research will be a complete failure if we cannot collaborate ethically, responsibly, effectively with community members. So I'm on a team that got an NSF award through the Navigating the New Arctic program, which is one of the NSF's 10 big ideas, if you've been following the NSF's research sort of priorities. And the goal is to study an urban setting to see how climate change is interacting with infrastructure, built infrastructure. Urban, we're studying Utqiagvik, Alaska, which is the northernmost city in the United States. You can see at the top of this map, it's that red dot. It's the very tip of Alaska on the North Slope. There's about 4,000 people there who live there. They're majority Indigenous, Alaska Native. And to understand how their infrastructure is being affected by climate change and the reverse, how the local environments are being affected by the infrastructure that they've built, we absolutely rely on them. Not only are they living, with that infrastructure day in and day out, they also are drawing on about 12,000 years worth of human occupation at Utqiagvik. So lots of Indigenous knowledge, lots of traditional knowledge, lots of just a massive archive of climate knowledge and how to adapt to it. So we are showing up with the machines in this photo. This is my collaborator, Matthew Jull, who's in UVA's architecture school. And he's building a sensor tower with some students in Charlottesville. And this sensor tower has all kinds of micrometeorological sensors. So that can measure precipitation and temperature and solar radiation and lots of other things. And so the idea is we're going to plant these at various points in Utqiagvik to observe what happens between infrastructure and the local environment over the next 5 years. And so we are a team of environmental scientists and architects and social scientists. And you can see I put the residents of Utqiagvik on our author list because we can't do this without them. And really, we're doing this for them. We hope to get knowledge for environmental science and social science and architecture, but really our hope is to study how infrastructure and the environment interacts so that we can give some design guidelines to the city of Utqiagvik in terms of where they should develop, where they should build, where is the permafrost most stable, which design of housing best resists the wind, how can we best build structures to prevent coastal erosion, right? Utqiagvik is right on the ocean. So yeah, this is a project in service of them. And we also hope that all of our fields will learn from it too. So let's talk a little bit about Arctic climate change. So Utqiagvik is in the Arctic Circle, and this is what happens when permafrost thaws. You can see the road on the left is all wavy. Roads in Alaska are mostly built on gravel, not cement, because the ground moves so much that the gravel is more sort of forgiving. But still, this is a dangerous road, and especially if it changes enough that it opens up a chasm, a pothole, it's really unsafe, particularly when there's ice, which is most of the year in Utqiagvik. Also, structures start to fail because the ground underneath them is softening, right? Thawing away. And then this is what the ground looks like when permafrost thaws, and all the water that was locked into frozen soil and also all the carbon is released when that permafrost thaws. And so then we get these very weird called thermokarsts, very weird geological formations that are tough to build on, and water moves in unexpected ways. So there's issues with flooding, there's issues with salt water coming into the freshwater ponds that Utqiagvik uses for drinking water. So lots of infrastructural issues throughout the city. Also, another issue that the Arctic has that most of us don't have the privilege of not worrying about is oil pipelines. So there are a lot of pipelines in Alaska and also in Siberia, in the Siberian Arctic. So here's Here's Utqiagvik. And so one of the main problems with permafrost thaw is that pipelines can become broken or unstable, and then there can be fires. And this has been a major problem across Siberia and across Alaska. So here are some ways in which the community is already adapting. As I said, people have lived in Utqiagvik for over 12,000 years. So they have deep expertise about how to survive in this Arctic climate, except that it's changing faster than it ever has before. So we're learning a lot. Our team is learning a lot about resilience, cultural resilience from especially the Indigenous members, the Indigenous residents of Utqiagvik. And so, for example, this picture on the right is the Utqiagvik coastline. You can see the beach. There's the Arctic Ocean. Gorgeous, gorgeous city. And so Utqiagvik used to be a major oil center for the United States. There used to be a lot of money in Utqiagvik as a result. And so these are old rail cars. You can kind of see that these are rail cars buried in the sand. And this is to prevent coastal erosion caused by sea level rise. All right, so that the ocean stays on that side of these train cars to protect the city, which is on the other side. So what an amazing example of reuse and making do with what you have, because Utqiagvik is remote. It's hard to get things there. You have to fly basically all supplies in by airplane. It's very expensive. And so they took basically trash, right? These abandoned rail cars, probably from the oil boom, and repurposed them as a way to hold their beach in place. Brilliant. And then on the left are pictures of our team deploying ground penetrating radar beneath a house in Utqiagvik. So all the houses, all the buildings in Utqiagvik are sort of 5 or so feet off the ground to try to keep them warmer, right? You don't want to build right on permafrost because it'll suck all the heat out of your house. And so we're spending a lot of time crawling beneath people's property with ground penetrating radar lines to measure the permafrost below and see where is rock, where is ice. And again, people are very concerned about their houses collapsing. Again, the cost of living is very high in Utqiagvik, and people cannot afford to pick up their house and move it, right? Or to build a new foundation because the foundation is melting. So this is very much a like, how do we help them now situation, as well as how do we plan for future changes caused by climate change? So again, this is a moral argument and an epistemic one. So it is more ethical to work with communities in all cases than to assume that we are serving them or acting in their interest, right? Nothing about us without us from the disability justice movement applies to all communities. And of course, people who live in Utqiagvik have sovereignty over their knowledge, their Indigenous knowledge, their traditional knowledge, their experiential knowledge, their expertise, right, of living in this climate. They have sovereignty over their land, particularly Indigenous sovereignty. And the movement in data ethics is towards Indigenous sovereignty over their data. So that means that any data that we collect on their land, on residents' land, belongs to them and not to us. And so this seems sort of obvious when you put it that way, but it's very different from the previous research traditions where scientists show up, do a bunch of measurements, and leave, right? And leave nothing behind for residents, don't produce knowledge that the residents can use, sometimes don't even share their results with residents, or they're studying science just for science's sake rather than for anything that would be useful to living in the Arctic. And so our team is facing really interesting challenges about how to respect Indigenous data sovereignty, how to collect data that are useful for people who live there and accessible, not only because the internet access is very challenging, but also comprehensible, right? If we don't have a lot of data scientists living in Utqiagvik, how do we make this data relevant for them? How can we display it, for example? What kind of dashboard of temperatures across the city might be useful for them? And of course, this is particularly hard to do because Utqiagvik is very overstudied. It has an airport, so basically all people who are studying the American Arctic do studies in Utqiagvik just because it's more accessible than some of the more remote villages. And so there's a long history of exploitation by scientists. So what we call parachute science, where people arrive, take their samples, take their data. Sometimes they take social science data, like interviews with people who live there, and then they disappear. Okay, so again, if we're arguing that the indigenous sovereignty of land extends to data, this is a serious moral and ethical and responsibility mistake. So we need to overcome those challenges. First of all, the history of exploitation. And crucially, we can do better science with the community members' help. And so, for example, we are really interested in permafrost characterization. So that means, like, what is the permafrost made of? Is it mostly soil? Is it mostly water? Is it rock? How do we understand that? What can we actually see with the ground penetrating radar data? And our collaborators in Utqiagvik, who are various civil organizations, as well as some individual sort of residents, private residents, they said, well, we don't really care about that, but what we'd really like to know is, how do we save our ice cellars? So Utqiagvik is a whaling culture. They collect whales in the fall and the spring and store them in ice cellars, which are cellars dug into the permafrost. And they've been doing this for thousands of years. And the ice cellars are now thawing along with the permafrost. And so the whale meat is spoiling. And this is not only a loss for subsistence living, which most people in Utqiagvik practice subsistence whaling and subsistence hunting and gathering. The loss of the ice cellar is also a major cultural blow, because the whale is a crucial part of the sort of worldview of the Inupiaq culture. And the ice cellars are considered to be the whale's home on land. So the whale gives themselves to the whalers take the whale home to the ice cellar. And so if the ice cellar is thawing, it's a disaster. It's a sign of disrespect to that whale. And so there's intense cultural loss in these sort of apparently simple forms of infrastructure. And so then we tried to change our research questions to be more about, what is it about permafrost that preserves meat? Because the town of Utqiagvik bought some sort of industrial deep freezers and put whale meat in there, and they said it doesn't taste as good. It doesn't work. It doesn't meet the cultural sort of significance of the ice cellars. There's something chemical that's happening in them, not just freezing. It's not just about temperature. And so that's actually a really fascinating question scientifically, as well as with deep cultural meaning for our partners in Utqiagvik. Another instance in which we are reliant on their expertise is trying to decide where we're going to put all of our sensors and where we should do ground penetrating radar surveys, which really relies on asking the residents, where have you seen the ground move? Where have you seen flooding? Whose house is crooked? Okay, those are all indicators that they know that can help us decide where we can watch the most things happen. And that's sort of horrible to sort of watch someone's house fall down. But again, the hope is that we'll learn from that failure how to build better, how to build structures that are going to be more resilient. And of course, our residents, our partners, have a very challenging role to play, which is to stop us when we're wrong. And so we showed up, saying, we're going to bring ground penetrating radar. We're going to do these surveys of the permafrost to tell you where it's safe to build. Isn't this great? And they said, we have 12,000 years worth of archaeology underneath us. You can't run ground penetrating radar over our sacred sites. And so thank goodness, right? Thank goodness they were kind enough and respectful enough to stop us and to tell us where those sites are, because we certainly don't want to do them any harm, right? Or do them any disrespect. And so we would have done bad science. We would have done offensive, insulting science without their guidance. And they didn't have to do that, right? They could have just said no. Instead, they said, we have this concern. Here's a map. Avoid these areas, which is going to make our research much better. Okay, so I just want to bring some of this together to argue that understanding research teams as communities of practice is more inclusive than disciplines, right? If we're all doing the work together alongside each other, we're all learning, we're all coming up with new ideas, we're all correcting each other, and that's the best way to build a community. And then I hope you've seen that incorporating diverse standpoints, such as people who have a variety of education levels, including none at all in science, produces more comprehensive, reliable, respectful, and useful knowledge. And also, everyone who participates in research contributes knowledge and community building and opportunities for learning. So I think we're easy. It's easy for us to say, yeah, collaborators contribute labor. They contribute more than that. Even if it's hard for us to recognize, they absolutely do. Even the undergrads sitting in the lab and telling jokes is lifting everybody's spirits, bringing everybody more together, bringing a sense of community building. And that's really crucial to knowledge production. And then, of course, this idea of peripheral wisdom, which I love, that we need outsiders to tell us when we're in the wrong and when we're in the right. So then that takes me back to my original question, which is who then should count as a collaborator ethically, normatively? Who should we consider to be collaborators? I hope the answer to this is obvious, that it's everybody. So then let's move back to ethical AI or ethical research, ethical science, ethical technology. What does this mean in practice? What can we do? So I would contend that we can't build ethical technology or ethical knowledge without ethical collaborations. It's the first crucial step. And so some ways to do that are appreciate technicians, right? If we pay them more, if we say thank you, if we make them authors, if that's what they're interested in being, they're going to be more committed. They're going to stay in that lab. They're going to work harder. Okay. They're going to think more deeply about what they're doing, all of which is good for knowledge. We should listen to undergrads because they can be a source of inspiration and new insights for the rest of us. We should partner with communities, truly partner, not just show up and try to do research that we think is for their good, their own benefit, right? We can only do that through their partnership, really, if we're in like a helper role, a service role. Because of course we can't solve social problems without the help of the society we're trying to help. All right, so here's some steps. Here's some practical things that I hope participants in this innovation lab and everybody can do, will do, to help establish ethical collaborations as a cornerstone of collaborative research. So first of all, we need a diverse team in every sense. Okay, expertise, identity, career stage, experience, all of those things are going to make better knowledge. There are people who have expertise, who study how best to do team science, people who belong to the science of team science discipline. They have a really wonderful website called Interreach, which has some resources on how to build an effective team, especially in science. There's some publications that have come out of this movement that have sort of practical guidelines for research teams, one from the National Research Council and one from the National Cancer Institute. Both of those are available freely online. So my role in most of my projects has been as the social scientist on a team of scientists and engineers. And that is not enough. That's an important first step. A lot of funders now require a social scientist or an ethicist to be on these large collaborative teams. But let me tell you, it's not enough. One person alone can't ensure ethical collaboration. It's too hard. It's too complex. And so I would argue that instead of having one facilitator, I would train everybody in facilitation skills. Okay, there's lots of webinars, workshops where you can learn how to work well with others rather than outsourcing it to somebody else. It's better if we all do it together. We all have skin in the game. And then finally, most importantly, we need to practice trust, respect, and listening. Actually do it, not just talk about it. So here are some ways we can do that. One is to write a memorandum of understanding. Lots of teams do this. Sometimes it's pretty formalized, and it's deciding things like authorship and data sharing. Who is the leader? Who is responsible for mentoring? How do we handle complaints? So lots of teams do this already, and we should all do it, and we should follow it, and we should remember that it's a living document that should be updated, and it should be a starting point for building consensus throughout the life of the project. So you can Google around and find examples for these and some templates. There's something called the contributor roles taxonomy that I think is really helpful, that lays out all the kinds of work that are part of scientific research and then helps you decide how to label a contributor. So beyond my list of, technicians and students and volunteers, it breaks it down more into like data analysts versus data creators versus data interpreters. Okay. And then that can help you figure out how people in your team fit together. This should be obvious, but we should respect everyone's contributions with pay. Okay, I talked about volunteers a little bit and students who would sometimes work without pay. We should pay everybody for their time. And intellectual property. Okay, so everybody's making an epistemic contribution. That should be recognized. And that's going to be different in different fields, and different contributors are going to want different kinds of recognition. So that's got to be a discussion among your teammates. How do people want to be recognized for their contributions, both of labor and of knowledge? And there are two documents that are based on each other, and they're lovely, called the Collaborators Bill of Rights. These are written by scholars in digital humanities, and it's really about defining the roles of collaborators, and particularly of student collaborators, how to avoid exploitation of various kinds of workers. And then, of course, inviting and responding to feedback, creating spaces for open communication is a crucial part of team science. Partly this is to inspire reflection, just like an undergrad asking a question is going to make a grad student stop and think through what they're doing, and that's good for the science. If we invite reflection among our team members, then we're all going to stop what we're doing and make sure that what we're doing fits what we actually want to be doing, what we should be doing ethically and morally and epistemically. Thanks.
Kaylin, that was fantastic. And it gives us so much more to think about in broadening the ethics of kind of biosciences so much more broadly. As we, you talked about working with engineering teams going to remote locations and working with local communities and indigenous communities and you mentioned trust, which I think is just so important, because so many of these communities have they've been exploited. This is like, okay, now there's another group of probably predominantly white people going to come in and tell us how we should be living our lives, and they just, after the umpteenth time of this, possibly over decades and decades, they're not going to be very trustful, and people are going to come in and collect their data points and go away and never see the results of that again. So I think that's so important, and it's important not only for dealing with indigenous peoples, wherever they are, Alaska or Hawaii or here in North America, but also in some of our biosample data communities that we go and get data from. So people with autism spectrum disorder, people with mental health disorders, people with other neurological disorders or other things. We tend to they're sort of a means to an end, right? They're going to get us the data point we want. We're going to go out and write great papers. So I think that's was such an important statement, and I'm curious about your own experiences with this, what you have seen in terms of the positive feedback you've possibly gotten from the Native Alaskans in your own work.
Yeah, thanks. I really didn't even talk about research participants, and Indigenous data sets are an amazing example of potential exploitation and potential mutual benefit, right? If those data are used appropriately, respectfully, there can be a lot of good that can come out of biomedical collaborations with Indigenous communities. And Kim Tallbear is a scholar in my field who writes about Indigenous data rights over biosamples, and her arguments are fabulous on how to do that well. And so for us, we're still sort of figuring out how to best serve our partners in Nutqiagvik. I told you some examples of how they've already sort of corrected our course. Yeah. Thank goodness. Another project I did with Charlottesville residents is maybe a better example of that, which is advocates in Charlottesville were pushing the city to build an open data portal to share the city's data online publicly.
Yeah.
And so I was working with them to try to figure out what that portal should look like and what should be on it and who should be in charge of it. And we came up with really different goals between what the city wanted and what the citizens wanted, and what people who didn't know anything about data wanted, which was me, right? I have no idea how to use open data sets, except that I knew that they were a good thing. And so how do we make this object, this portal, work for the city with its concerns about privacy and its concerns about democratic engagement, right? Open data can be a way to pull people in and help people develop an argument for the need for change. And the data advocates who just wanted all the data and wanted it now. And the rest of us who would like to learn what we can learn from using these kinds of projects. So yeah, bringing together all those different stakeholders is crucial for the success of the research, and also crucial for the success of addressing real social problems like infrastructure, like democratic engagement, like government transparency.
Yeah, I like that. And I was also struck by your comments about inclusion of, say, undergraduates in the research enterprise. And I'm old enough now myself to have seen a lot of people who are older than me simply just flat out refuse to include undergraduates as part of, on an author list. Just, oh, they're undergraduates. What do they know? They were just the pair of helping hands. And so we don't need to give them any sort of authorship credit. And in my own life, I've tried to do that where possible, because what's the harm, right? In fact, it's good, right? It's good for that student. It like helps them. And one of the things, as somebody who's sat on a lot of graduate student admissions committees, is that one of the things we look for is we're paging through their application to say, how many papers have they published? And if it's, oh, they're not supposed to, or no, we don't allow them, you're denying them this wonderful, ticket to the research, ticket to entry into the research world that had you just given them the authorship, it probably would have gotten them past the door. So I don't know. I'm intrigued by that, and I'm curious if you've got any examples yourself, or you know of anybody who, for example, they were included on some early paper, and now they're like, I don't know, they're a national, they've run some big award, or they're now, some superstar who had that opportunity. I don't know if that makes any sense, but
yeah, no, absolutely. I think that's another argument for equity and inclusion, that if students don't have papers, they're not going to get into grad school, in engineering at least. Like, you're expected to have a paper when you graduate undergrad, and you have to communicate that expectation to the PI so that they'll put the undergrads on, and so that they'll rethink that assumption about, oh, undergrads don't deserve to be authors, or they'll plan. I've done this myself, where I plan papers that we were writing really for the benefit of the undergrads. Like, it's preliminary results, for example, like we're not going to finish the study while that undergrad is a student. So let's write up something now so that that student can be on it. And then we'll build on that paper in the future. And that's been great for me, right? It forces me to get some papers out the door. And then that student has proof of the incredible contributions that they've made. And I think a lot of people, I'm being a little facetious, because of course undergrads need a lot of training, just like anybody, to do research well. But one of the most valuable things I found about working with undergrads is that they show up. Every Tuesday at 1, I'm going to have a student in my office who's going to look at me really eagerly and say, what am I doing this week?
That's right.
Which keeps me on target and makes sure that I've done my part so that I don't disappoint the student. And that has actually been an incredible boon to my own research, just like the relentlessness of it, that you want the undergrads depending on you, and so therefore you produce. And I think only undergrads could do that. If it were a collaborator, I think we wouldn't be as quick. We don't meet every week with our collaborators because we're off doing our own things. And so undergrads can provide that sort of pressure / support to keep going.
Oh,
so, yeah.
Absolutely. And undergraduates I've had in my labs in various institutions, I've always tried to give them those opportunities, either to present a poster at a big conference, or to have first author publications on things. What's the harm? It's no harm to me. I'm still an author, right? I'm just the guy at the end of the list, right? But the people who are actually doing the work, give them that opportunity. And I had one student who I just thought the world of, and I always tried to make sure that she had opportunities to lead, the writing of papers and whatnot. This was while she was kind of an undergraduate, and kind of after she had graduated, but she was still working in the lab. She ended up with enough peer-reviewed publications of herself that she was on, that her H index was higher than some of the junior faculty that we were considering. And she's now she eventually went to graduate school herself, and now she's a graduate student. But I always thought, gosh, if we just were able to do that for so many more students, that would be wonderful.
Right. And also as a recognition of the work that they've done, not just to help their career, but to say thank you. They earned that. Absolutely.
And so one of the things about I guess bringing this back to ethical AI is as we're thinking about, we collect this data and then we use it to build models, and then presumably we want to make predictions about, like, I don't know, where permafrost is melting more quickly or what have you, and using computational models on that. How do some of these ethical considerations map themselves, if they do at all, into turning these things into code or into mathematical models? Do you have any sense about that?
Yeah, I do. And I think ethical AI is scary because we think it's so technical. We get
Yeah.
so focused on the math and the coding and the models and the predictive aspects, and it's easy to just say, just build the thing and we'll figure out who's responsible for it later. We'll figure out what your contribution was later. We'll figure out how we're going to share this later. And that's really dangerous. That's a way to exploit particularly junior research members. And underrepresented minorities are going to bear the brunt of that discrimination. And so it worries me about ethical AI that it's so, people think of it as being so technical, and it's not. Like, it's still a team of people working together to build this thing. And so we need to respect that team as a sort of living, breathing organism that we need to sustain and support and create governance structure for, and provide training and mentor, you know what I mean? Like, all of these things, there has to be so much learning on a team of people working on ethical AI because it relies on so many disciplines and so many kinds of knowledge. So yeah, I gave this talk bringing together a wide variety of fields on purpose to make the point that I think these recommendations I'm making are true for any field of research or design.
Well, you certainly touched on one of the main thrusts of our Biomedical Data Science Innovation Lab, is to bring these different voices together with different points of view and different perspectives, different backgrounds, different kind of sets of, skill sets that they can bring together. Because, so often, I don't know, how many times have we seen something where, I don't know, a bunch of people cut from the same cloth get together and do something and then say, hey, everybody, look what we built. You should all want to use this, or whatever it is. And the people who are not within that, you mentioned kind of the outsiders, right, will take a look at it and go, I would never have done it that way. And what you've created is completely useless to me. If you had my input, I might have been able to give you some different, more nuanced understanding of this area. And so anyway, bringing all these different voices together is such an important element of research, of ethical AI, and certainly part of our Biomedical Data Science Innovation Lab.
I'm so glad.
Yes. Well, I think we're about done. Caitlin Wylie from University of Virginia, thank you so much for sharing your insights and wisdom and ideas about team science and collaboration and what all that means for ethical AI. We really appreciate it.
Thank you.
Thank you, everybody, for joining us. And